I'm Ms. Vung. Today we're going to look at the tangent function. It is the third video in our circular function series. If you haven't seen sine and cos, please watch the previous video. This is the unit circle as we saw in the previous video, and in the previous video we also saw that sine is written as sin for shorthand, and cosine we wrote it as cos. And today we're going to look at tangent, and we're just going to write tan theta whenever we see tangent. We saw in the last video that sine theta is equal to y, cos theta is x. So what is tan theta? That's what we're going to look at today. This is the unit circle from last lesson, and we recall that cos is your x value for that point p theta, and y is the y value for that point p theta. So what is a tangent? The tangent line on a unit circle is the line that is tangent to the circle at point 1, 0. Let's have a look at what that means. So this is a point 1, 0. If I have a p of theta over there, then the tangent line would be the tangent line over here until it meets that line over there. So that purple dashed line is my tan theta. If I have moved the point to another point, then the tan theta would be that line over there. And I can move the point around the circle and make tan really big, completely small. We can see that tan is obviously bigger than 1 at the moment. But we also can notice that if I put the dot right in between the two axes, that I will get tan theta to be equal to 1. And we notice that this angle here is 45 degrees. And we know from previous exercises that tan 45 is equal to 1. Now we can visually see why. So tan is the purple line, or the tangent that goes through 1, 0, and it intersects the line of the point at theta. So what happens if the point is in the second quadrant? Then our tan theta would intersect that line down here, so it will be negative. What happens if the point is in the third quadrant? We can see that if I keep going with that line, then my tan theta, so my purple line, is also positive. What happens if my point is down here? Well, this one's pretty easy. We can see that it's also going to be negative. So we see that the point, so if our radian or our angle is in the second or the fourth quadrant, then our tan ends up to be negative. And if it's in the first or the third quadrant, then our tan is going to be positive. So over here it is positive. What else do we notice? We notice that we can draw two similar triangles where the height here is y, the base here is x, or the height here is sine and the base here is cos. Now, based on similar triangle, we have the vertical side tan theta over the horizontal side. The horizontal side for the big triangle is the radius, which is 1. So tan theta over 1 is equal to the vertical side sine theta over cos. So we can see from similar triangles that tan theta, getting rid of the 1 because tan theta over 1 is just tan theta, is sine over cos. So tan theta equals sine over cos. Memorize that. So we notice that cos cannot be 0, otherwise tan is undefined. So tan is undefined when cos is 0. When is cos 0? We've seen from previous video the x value is 0 up here and down here. So cos is 0 for these values, which means tan theta is undefined for those values. So tan theta is undefined at plus or minus pi over 2, because it could be there or there, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. Let's evaluate some of these tan thetas. Example 1. Let's have a look at when the angle is 0, what would tan be? Well, we know that the tangent is tiny, or in other words, non-existent or 0. Remember drawing that purple line? Well, 0 there, right? But we also can figure out as sine and cos. So we know that the cos is 1 and the sine is 0. So 0 over 1 is also 0. So that matches up with our purple tangent line. Example 2, evaluate the following to 2 decimal places. So we're going to use our CAS calculator. So let me bring it up. So I'm just in main, and then 10, 3.2. So bring up keyboard, and we have to make sure that we are in radians, and that's this section over here. Radian is rad, R-A-D. Now we go to trigonometry, and we click on 10, put in the value we want, 3.2, enter, and we obtain 0.56. 0.06, sorry. Let's do the next example. 10, -1. Again, you go to trig, 10, click on -1, enter, and we see that it's -0.1557. Rounded to 2 decimal places, it will be -1.56. Now, what happens if we want to do 100 degrees? So then we go to our calculator, we change it to degrees by clicking over here, so DEG, make sure it's DEG for degrees, then click on 10, 100, enter, and we obtain -5.67. Let's see if that makes sense. -0.567, why is it negative? 100, well, 180 is over here, 100 will be somewhere here in the second quadrant. So right past 90 degrees, so it will be in the second quadrant. And we saw previously that in the second quadrant, 10 is negative, so that makes sense. Let's just check our first two as well. 3.2, 10 of 3.2. So 3.2 would mean it is right past 3.14, which is pi. So it will be up down here. So 3.2 will be in the third quadrant, which gave us a tiny tangent of a positive tiny tangent, sorry. And 10 of -1, where would -1 be? -1 would mean we're going anti-clockwise. Remember, this is 3.14. -1 would be in this quadrant over here, the fourth quadrant, and we saw before that the tangent of the fourth quadrant was also negative. Okay, one more example, 10, 200. Again, tapping onto the 10 button, and then 200, enter, and we get 0.363 or 0.36, and check where is 200. So again, this is 180, 200 is over here, and we know that in the third quadrant, when we draw through the line, we see that the tangent is positive. So second quadrant, we see that the tangent will be negative, third quadrant is positive, and the fourth quadrant is negative. Okay, thank you for watching. Practice with the CAS and try to remember where tan is positive and negative. You might want to watch the video again to just observe what tan looks like, so your mind can remember what tan should be, positive or negative in each quadrant. I'll see you next time. Bye!